In this video, we are going to understand the notation and concept of permutation. In a dinner set, you have to choose soup, main course, and drink. So, what is the number of ways you can choose different dinner set? You have 3 tasks, you have 3 steps to finish. First step, you need to choose soup, 2 choices. And the second step to choose main course, 3 choices and 2 choices for the drink. So apply the multiplication rule, the total number of ways is 12. In example 2, you have 5 letters A, B, C, D, and E. So arrange them in a row. How many number of ways you can arrange? So you have to decide 5 tasks. Decide for the 5 position. So at the first position, how many choices do you have? We can put in A, B, C, D, and E. So there are altogether 5 choices for the first position. And if we have put A at the first position, then that means A could no more be at the second position. So the second position would be 4 choices only. And so on, the third position have 3 choices, fourth position have 2 choices, and the fifth position have only 1 choice. So, according to the multiplication rule, 5 times 4 times 3 times 2 times 1, we have a notation of 5 factorial. So you can associate 5 factorial as a going downstairs from the 5th floor and then down to the 4th floor, down to the 3rd floor until it will go to the 1st floor. So this is the 5 factorial. We can take use of 5 factorial when we are arranging 5 objects in a row, and the order does matter. In this example, it is quite similar to example 2, but this time we will only choose 3 letters to arrange in a row. So what is the number of ways of arranging 3 letters in a row? We only need to consider the 3 positions. So the first position, you can put in A, B, C, D, and E. So 5 choices. And second position with 4 choices. And third position, 3 choices. So this time, we don't need to consider the 4th and the 5th position because we only need to arrange 3 letters. So we could rewrite 5 times 4 times 3 in this way. That means all of them remove the last 2. So that is divided by 2 times 1. So it equals to all of them is 5 factorial, divided by the last 2 is 2 factorial. And 2 factorial, we can rewrite it into 5 minus 3. That is, all of them, we need the first 3 and don't need the remaining 2. So we divide it by the remaining 2 terms. And we define this as 5p3. That means if we have 5 objects, we choose 3 objects and arrange in a row. 5p3, which is equals to 60. So you can use your calculator to check 5p3, is it equals to 5 times 4 times 3? Both of them should be equals to 60. So to conclude, if we have to arrange n objects without repeating, is n factorial. So which means n times 1 smaller, and then 1 more, 2 smaller, and then until it's 3 times, until it's times 2 times 1. So it is also equals to n, I think choose n things. So another case is that we have n distinct objects, but we only take our objects at a time. So the number is n p r. So that means we will only need the first r term. That means we only need the first r term, and then we'll delete the afterward, delete the factorial afterwards. So it equals to n factorial over n minus r factorial. So that means we will only need the r term, and we will delete the remaining terms afterward.